Hello. So welcome back to our class session for Java CSC 200, and we are on unit 3 or chapter 3 that I want you to read about branching statements. So now let's talk about flowchart. So what's flowchart? Flowchart is just a graphical representation of a program logic. Like for example, if you have a program as sequence, so program logic can be sequence. You do statement A first and then you do B. Just like we said, prompt the user to enter their name and then we just print out hello their name. So do A to prompt user to enter name, do B to print out hello Mr. John. Alright, so now this is a sequence, and you can also look at a symbols for flowchart. For input or output, we like to use a parallelogram, and when there's a process, we can use rectangle. If you need to make decision, we use diamond. If you have to call a function or procedures, we use the rectangle with the two lines inside, and we have the direction of the flow as the arrows. When you start, we use an oval, and when you finish, we use an oval. Now let's start to look at another type of flowchart structures. We said we have a sequence. Now if we talk about branching means you need to make decision to go to either this left direction or right direction. Okay, so there's a branch going on at this point. The sequence, there's no branch, just go down. Step 1, step 2. Now when you get to the branch, you need to make decision either go to what is true. If the decision that you make on the X statement and give it to true, then you have to do A. If it's false, then you have to do B. Alright, so this situation could be an example. If today is snow day, then if it's true, then there's no class. If it's false, there's no snow, then we have class. So this is going to be making decision either to do A or B. Another type of decision is going to be called repetition statements. Okay, so or iterations. That means you're repeating doing the same statements over and over and over again. Okay, and this part is going to be on chapter 4 of your textbook that I'd like you to read this too. So let's take a look at this. For example, the situation is you have to come to a class to learn Java for 16 weeks. So we're going to set P stand for the number of 16 weeks. Now this coming to the class for 16 week, every week that you come, the number is going to increase. So we're starting, say, while the counter that you have, which is week 1 that you come, less than number 16, then you're going to come to class. And then when you come to class, you start to count, increment the number to 2. Week 2, 2 still less than 16, you still come to class. 3, 4, 5, 6, still less than 16, and over until you get to 16. So that's the last class that you go, and 17 come. Then there's no more class, then you just go out of the loop. Right, so it means that while P statement is true, then you do A. Like the number of week that you come to class still less than 16 is true, then you come to class. Until it's more than 16, then you just do not come to class. So this is a statement for do while. Now another one is case. So what's case here? Case is just like a decision statement as a branching, like when you do if else that two branches. But case statement you can have more than two. Like for example, case score of the student is 100 or between 100 and 90, then you get an A. Case student score less than 90 but greater than 80 and equals, so you get B. Case between score between 80 and 70, you get C. Case score between 60 and 70, you get D. So this is switch case, when you have to select option more than one or have more than two branches. Let's look at an example. So this is a flowchart to show how to find average of 10 numbers and print it out. So now we're going to combine the symbols and the constructs of your flowchart together. You can see we start with an oval statement, start, and then the symbols that we use has to be an oval. And make sure when you want to prompt the user to enter the numbers, we're going to use the parallelogram. So get the numbers. Now after you get the numbers, you can start to add numbers. Since we said in order to ask user to input number for 10 number is deal with repetition statements, so we need a loop to help. So this is the decision to make. Say we're gonna say we keep counting if the numbers that the user enter equals to 10 numbers yet. If not, then we go back and ask user to enter numbers and add the numbers and check. If it's still not, go back, check, go back until the user have entered 10 numbers. Then you just divide by 10 and print out the average and end. So this is a flowchart to show how to find average of 10 numbers. Now, why we need to learn this? So far, we learned how to write a program using Java. Alright, so we can use Eclipse to help, and we know we can either use Eclipse or Notepad to write a program. And I have shown you how to do those. Now, to write a program is not involving with knowing Java syntax, but you need to know how to put your idea together to write a program. Writing a program just like in a book. You need to think about, you have to put a program together in a way that the audience can read it. So you try to translate your idea into the paper. So for example, I'm going to show you a simple flowchart. Okay, I'm going to write a program to add two numbers. Okay, I'm going to say adder. Right click, new class. So what I'm going to do, I'm going to write flowchart, pseudocode, and Java program at the same time. So we just learned how to use flowchart. Let me show you how to write a program with pseudocode. So pseudocode is just a statement. Okay, it's just a way that you represent your algorithms or logic. So let's look at an example of some keywords here. This is pseudocode. We just use the keywords, right, to prompt, to read, to prompt, to read. calculate and display. So prompt means when you want to get an input, okay, or display actually output, and read means you want to get input in. Now this example said calculate the bill when someone buys a specific number of some item. So this is pseudocode. Prompt for number of items being purchased. Read number of items being purchased. Prompt for price per item and read price per item. And then calculate subtotal and calculate tax and calculate for total and display the total. Alright, you may see that in pseudocode we use keywords like for input we can either do input, read or get. For output you can do print, display, show and prompt. For compute, calculate and determine. Initialize, set or edit. Add one, increment or bump. For decision we can do test, if then else or while do. So let's look at another example. So we said we want to calculate your two children's allowances based upon 75 cents per year old. Alright, so we're going to set the rate equal to 75 cents per year. Right, so we said this is the known values. And then we said the inputs. So from this statement you should be able to explain what should be inputs, ages of children, and how to calculate the allowance. We said age time rates. That gets you allowance. And what is the output? You want to output allowance for each child. Now after you define some values for key values, inputs, calculations and outputs, then you can start to write your pseudocode. Pseudocode could be prompt for age of child 1, and then you read age of child 1. Now we have to prompt again for age of child 2 and read age of child 2. Start to calculate. Allowance for child 1 equals to age of child 1 times rate. Allowance of child 2 equals to age of child 2 times rate. Then we're ready to display allowance for child 1 and display allowance for child 2. So that's how we do the pseudocode. Now if we talk about pseudocode that dealing with if-else statements, so let's look at the question again. Calculate one child's allowance based upon 75 cents per year old if he or she is under 10. So in this case we need if statements. To check if he or she is under 10, we're going to use 75 cents per year old as the rate, and we set it to young rate equal to 75 cents per year, and $1 per year if 10 or over. So we set older rate equals to 100 cents per year, and we know that the break age equals to 10. So this is going to be when you check for if age is less than 10, right? We know input is age of child and calculation is same, allowance equals to age times rate, and outputs for allowance. So let's look at pseudocode now. Prompt for age, read age. If age is less than 10, then calculates allowance equals to age times young rate. Else calculate allowance equals to age times older rate. Then display allowance. Alright, so now we learned how to do the pseudocode here. And we just learned also how to write a flowchart. So let me show you how to write a flowchart for this type of question for the allowances here. So you can either use Word to insert a shapes. Under this we have flowchart, so we can use an oval to say this is a start. I right click and add the text and say start. Now after start, we want to, I'm going to copy this and paste when we have to end. So somewhere at the bottom we're going to put this. Okay, so I'm going to drag and drop right around here first. Now between this we have to do the logic, and we try to represent in the graphics format instead of text like pseudocode. So in the real world you can either use flowchart or pseudocode. You don't need to do both, but for this study and your assignment too, you have to do both. Alright, so we got a prompt for each. So prompt for each. Prompt, we can use the parallelogram. So let's insert the parallelogram right there. Okay, and we can just add the text and say like enter age, and then read the age. After the user enter, you want to read the age in. So going to read input and output, you use the parallelogram. So read age. Okay, so we have enter age and read age. So what's the next step? Now we said if, when you're dealing with if, we need to make decision, and decision symbol is a diamond. So let's bring it in. And what is going to be in here? You want to make sure that you want to check if this is equals to 10 yet, or less than 10, or greater than 10. So we said the rate is going to be if age less than 10, right? So we can say, you can either say age less than 10 with the math less than symbols. Okay, so if age less than 10, what would you do? So that's going to be if L is a branch, so there are two directions. I go to the left or go to right. So we said we're going to make two results process. You have to process, right? At this point we have to process, either do the left. If it's true, that means age less than 10. So if it's true, you're going to say allowance equals to age, right, times young rate. Now our young rate we say is 75 cents right here. So if you never set a variables in beginning to young rates equals to 75 cents, we can just multiply 75 cents here. Now if it's false, it's going to do the right branch, which is, that means the age is greater than or equals to 10, and the rate is going to be 100 cents. So that's $1. So that's how we get to and compare to pseudocode here. So now we done the true and the else statement false. So we might want to add some text to let us know that when you get it here, you talk about true. Let me add the text here. Insert true. It doesn't have to be that huge. So if it's true, we do this. So if it's false, So just copy and say FALSE. You do that right. And of course we need to draw an arrows too. But before that, let me finish up by I need to display the allowance. So when both are done, they just come back and join and display the allowance here. And then we're done, just get to the end. Alright, so now the last thing that we need to do is just draw the lines for connections with the arrows. Then we know this is a flow. So these are the direction that we go. And then here, so if it's true, we go to the left. If it's false, we go to the right. And then we connect them all back. And we are done by go to the end. Alright, so now we just need to connect the lines here. Okay, when it's true, we go down here. And when false, we go to the right. Just try to connect the line. Alright. May not be evenly, but that's fine. Now, when you get out here, you just need to join back. So we need another line to make it joining back. Like that. And this pretty much just come back here. And we pretty much just join the line back to this. And that should be a flowchart. Now, I'm going to show you a program now. So we have pseudocode, flowchart, okay, and let's look at how to write this program. So I was thinking about doing adder, but actually we can just do this program now instead of adder. So I'm going to say allowance. So now what I'm going to show you is, like for example, I have the question the assignment say write the program, right, to calculate one child's allowance based upon 75 cents per year, or if he or she is under 10 and $1 per year if 10 year or over and over or over. So what I'm going to do, I'm going to put that inside the comment section. Remember we talked about that for Java doc, and we're going to say, okay, this is the purpose of this program, right, or the name of the program. So to calculate the allowance here based on the condition here. Alrighty, so we pretty much going to use this or use this to help writing a program. So let's see how it works. So I'm going to look at flowchart. We know that we need to translate this start just like this start, and to enter age, we know enter age. What would you do to enter age? Enter age in Java, you pretty much just want to prompt the user, right? Thus an output symbol to prompt. So system.out.print and say enter age. Alright, so we know that this logic will work for sure for this statements that we have, because we already proved it from flowchart. The only concern now is just how to translate your flowchart into Java code, right? So like I said, when you write a code, you should be able to write the Java code and write the logic. Now we try to use the logic tools, which is flowchart or pseudocode, to help to write the logic. And now you don't have to worry about logic. You only worry about how to write Java code by translating the logic to Java code now. And we did show you how to do that, the first one. The second one, to read. You know that in order to read in Java, you need to use scanner, right? So we gonna use scanner new. If you read from the keyboard, we have to use system.in. Now to read in Java, after you instantiate the scanner, you need to import, and then we can read the age by, you start to define int age, right? Age can be an integer, so int age equals to keyboard dot next int. So that's how we're going to translate that input read age into this. Alright, so now we set the conditions decision. This is an if, right? So we done with this, we done with this. So let's do highlighter, done, and done with this. So we have to do this part, age less than 10. So age less than 10 mean if, right? Decision branching left or right. So that's if. If it's looping back, then that's gonna be loop, and we're gonna learn how to loop later in the next unit video. So in this case, we're gonna do if else. So if age less than 10, right? So what do we do if age less than 10? So it's a good practice to just open your curly braces. This is the if else syntax in Java, right? Else open and close for you. So always open if close, if open else close else right away. And when it's true, it's going to do the left statements, which is you're going to calculate your allowance. So let's declare an allowance. So this can be double because we're dealing with 75 cents. Okay, and now we can just say allowance equals to the age times 0.75. Right, so we're gonna do the same else. We're gonna say else, that means it's false. When it's false, so age times 1.00. And then we're pretty much done by last statements display the allowance. So print out, and this is going to be a variable, so we just do allowance, and then we pretty much end. This is int in Java int. That's it. So we're checked here, we're done. Let's revise. There, we used this already, we're done, and we just print display allowance. So we're done at the end. So we just pretty much just use the tools to translate that back. Now let me right click and run as Java application. Okay, so let me save the program and see. Right click again, run as Java application. There you go. Enter age. So if it's 10 years old, it should give me $10. It works. So right click and run as Java application. 9, so 675 cents. Alright, so thank you for watching this video. So again, what have we learned today? We learned pseudocode, flowchart, Okay, so this is pronounced without P because pseudocode flowchart. And how to write pseudocode, how to write flowchart. Pretty much these are the tools, okay, to write your algorithms. Algorithm is just like the logic thinking that you have to deal with the problems. This is the problems, and you just write it out. Then you can translate back into Java code. Right, when you use pseudocode or flowchart, you just don't need to worry about syntax. Only worry about how you translate your logic out. Alright, so hopefully this helped, and if you have questions, concerns, you can post. Right, talkverbal.com. Okay, if you have questions, concerns, open that and what's that. Thank you for watching.